As they say, no math, no problems. What the heck?
Tagon.
So this is going to be a bit of a, a side video that I wouldn't normally otherwise make, but I thought I would sort of give an overview of what's to be expected from this channel over the coming months. I applied to go to graduate school for mathematics starting in September of this year and got into a bunch of schools in England. Then I decided now wasn't really the right time for me to do that. I'm gonna, take some time to go traveling around the globe while I've got my youth. And in the meantime, I decided to, make a YouTube channel showcasing mathematics that I think is really cool. In the meantime, before I do eventually do grad school, which I think I'd like to do eventually, I think it would be good to reaffirm the knowledge that I had to learn in my undergrad, in my various subjects that I took, the different math classes, by going through the texts and posting videos, answering questions, and going over lessons as part of my YouTube channel. Not only for viewers' benefits, but also for mine. Because if I can explain the concepts well enough, simply enough, then that means I probably understand them well enough for myself. And if I create my own videos that I think are satisfactory, then I can use those as a resource for myself, as well as other people using them as a resource for themselves. So of the things that I'm probably going to need to reaffirm, since it's been a year since I even took a differential equations class, I have a few texts that I think I will eventually go through. Some are, college textbooks, some are, I wouldn't call them, oh, there's a fly in my room, son of a, I wouldn't call them pop math books, but they aren't college texts. They're not meant to be part of a semester's curriculum. So I've got the textbooks that I expect to eventually try to go through in some sense. I've got Understanding Analysis from Springer by Stephen Abbott. So this is essentially, well, what's analysis? Analysis is like the nitty-gritty study of the foundations of calculus, essentially. And when you get to calculus, it's still called analysis. And that's sort of the broader term. Essentially, this is like, you've got Cauchy and Weierstrass and those mathematicians from the 17 and 1800s, I think it's probably just the 1800s actually, maybe, who created a rigorous foundation for the ideas in calculus that you sort of just take for granted when you first learn calculus, right? You learn about limits, but like why is that necessarily allowed? Like why are you allowed to get as close to something as you want? Why are you allowed to go to infinity? Like what does that mean in a rigorous sense? And so that's what real analysis is about establishing those facts based on good axioms, good rigorous theorems and definitions and all that. And it's very interesting. It's kind of dry. When you're limiting yourself to literally a one-dimensional quantity like the real number line, it can get a little boring. Thankfully, there's a follow-up subject with much cooler numbers. Some would call them more complex. We've got complex variables and applications, which is Brown and Churchill. This is the book that I had for my complex analysis class, which was one of my favorites. Even though it was an 8 a.m. class, I somehow found joy in this. I love this subject. I think complex analysis is wonderful. So, after following real analysis, if I get through the book, I will go into complex analysis, which I think would be a very, very good thing to try and go through and cover in general. And so that's one of my goals. One of my favorite subjects, just because once you get to prime numbers and irrational numbers and all that, I just find that subject very, very interesting. The study of numbers themselves, number theory. I have Jones and Jones's elementary number theory. I don't know if that's coincidence or they're like together or something, but this is also from Springer. I believe the complex variables one is from McGraw-Hill, so this is from Springer. This wasn't my number theory class text. My number theory class text was this gigantic thing. It's absolutely enormous, and I just can't stand this textbook. This is Elementary Number Theory and Its Applications, 6th edition of Rosen's book, and this thing is so dense, and I don't know why it's so enormous, because I remember students in my class had much smaller versions of this book. I think the pages are just thinner, but this book is like, I find it so like annoying to get through that I just decided to buy a different elementary number theory book because not only is it paperback, lighter, and thinner, it seems like it's almost more forgiving just based on what I'm able to, just based on what I'm able to glean from it. I haven't read it yet, but this is just, this book is just so hard to get through, and I couldn't stand it, so I got a different one, and so I'll be going through this book eventually. I'm just going to put this hunk of back. And I might go through this just because it's, I don't know, this was one of the weirdest classes I've ever taken. If only because this textbook is really strange, and it's got typos, which is odd. It's Modern Geometries by Smart, and it's the 5th edition, and it's got some pretty cool inside covers, but it's literally got a typo in the table of contents. Where is it? They say, where is it? There it is. Hyperbolic geometry instead of hyperbolic geometry, which is geometry in negative curvature as opposed to what we're used to, which is Euclidean geometry, which is flat space. There's also elliptical geometry, which is geometry on positive curvature, like the surface of a sphere. But this book is very strange. I don't really know how to describe it any other way. It's very hard to get geometry, like this kind of geometry, across in like a intuitive way. And so I'm going to do my best to get through this if I do. This is not my main focus. I'm much more interested in analysis and number theory, which is why if I ever study analytic number theory, I'd probably be pretty happy about it. And on to the last textbook that I have that I think I will cover, unless I, of course, get more, is actually one of my least favorite mathematical subjects, but I feel like if I just give it a chance, I can probably enjoy it and learn it a lot more. I have Lee's Abstract Algebra. So this is, again, from Springer, and it's an introductory course on it. And I think, group theory and that never really, stuck with me in the sense that I'm not particularly fascinated by it, to be honest. But I think I have this image in my head where I desperately want to understand why it is that you cannot solve in general 5th degree polynomials and above, and I know I can't just understand that immediately because I have to get to Galois theory, and that means going through this. Of course, I've taken all of these courses before, and I did just fine in them. It's, as time passes and you don't use it, you kind of lose it a bit, and so I feel like it would be beneficial to go through this, even though this isn't one of my favorites. Those are the official college undergraduate texts that I have. I have a few almost like pop math books. Here we have, oh god, this has got cobwebs on it. I really haven't looked at this in a while. I must have gotten this when I was in my sophomore year of college. I have Boros and Moll's Irresistible Integrals, which is kind of true. The only issue that I have with this book is that it seems to just kind of jump right in. Not in a good sense, like, hey, we're just doing math. It's like, it doesn't really cover the steps very well. And not that I'm not, adept at thinking through stuff. It's just, it's so sparse in its way of getting from one step to the next in a lot of ways that it's kind of hard to follow. So I'm going to do my best with this one. I don't necessarily know how much of this I'll get through. I'll do my best. And then after that is one of my favorite books. I've actually just read this book because it's so interesting, is Havel's book on Eulers Constant, the Euler-Mascheroni constant, little gamma. The limiting difference between the harmonic numbers and the natural logarithm function. It's got a very, very nice matte finish cover. It's very lovely. And I loved this book. I think this is amazing. I think this is a fantastic mathematical read if you want to learn about one of the coolest and most ununderstood, not misunderstood, ununderstood numbers. Like, they don't even know if this number is irrational or not. But this was just a fantastic excursion into such a fascinating constant, and I very much recommend it. I'll be going through some of the awesome facts in this. They present many, many cool sums, integrals, things like that in this, and so I'd like to get through that. This is a very small book from a while ago, and if I feel like covering the ins and outs of it, I will go through Artin's The Gamma Function. Very interesting function. This is capital gamma now, not lowercase gamma. This is the function, which is the analytic continuation of the factorial function to numbers other than natural numbers. So this is a very small book. It doesn't have a lot in it. But again, this book, because it's so small, it seems to... It's I don't know what, I don't really know how to describe it. Maybe I'm just not as well versed in this kind of topic somehow, what it is to find analytic continuations of things while also caring about the logarithmic convex aspect of it and all that jazz. I don't know. I just think I probably just have to go through it. So I may go through this. I don't know. Finally, one of my favorite like standalone topics in mathematics, which seems to not get that much attention, to be honest. It's very strange because I feel like it would be very interesting to see where certain things go. Which of course this book has, is the fractional calculus. So the questions of derivatives and integrals of non-integer order, which I find very, very interesting. Dr. Payam has done a lot of videos on these. I think I've done a video on that? I don't remember, but I haven't, it didn't come from this book, and so I may go through this. I've gone through a bit of it. It's sort of printed in the same old fashion that the gamma function book is printed in, and so it's a bit dense to get through. I don't really know what it is about this style where it's like it's almost looked like it's printed in the 30s, which I'm sure it was because this book is actually from no wait, this is 1974. Wait, I thought this was way older than that. Maybe it's 1974. Copyright Academic Press 1974. Yeah, so this is not as old as I thought, but old enough that they're printing it on this weird looking ink. I'll go through some of this as well because I find fractional calculus very, very interesting. And so that's all the books that I have that I think I want to try and cover it all. But I also have pages and pages and pages of personal mathematical explorations that I've gone through that I have to not only order, but literally put in order because I just kind of threw them all together from all the different notepads and notebooks that I've had over... I don't know. This isn't any. This is not college notes. This is just me doing math on my own because it's my preferred subject. It's what I enjoy doing. And I have done, you know, maybe not all video worthy, but I've done so much just off the cuff mathematics on my own just to answer my own personal curiosities. And I'm probably going to try and get through some of this at least and cover it on the channel. I also have on my Desmos account graphs that are just lists of different combinations, compositions, products, quotients of trig functions, inverse trig functions, hyperbolic, inverse hyperbolic functions, exponential, logarithmic, combinations of them all, sort of in the vein of my response to Black Pen, Red Pen, where he did an integral over sine times arc cosine over its domain in the real numbers, and I responded with an integral over the domain of sine times inverse sine, sort of any composition of those two things that you can imagine that yields a finite result. I have those in lists. I have no idea if any of them are like resolvable. You know, I'm just sort of put them together and we'll see where that gets us. And other than that, I have a list on my phone of other subjects that I want to cover, like the high school-ish lessons that I've got for further trigonometry, hyperbolic trig. I know that's not in high school, but it's really easy when you know trigonometry. A bit of complex numbers, introduction to calculus, Euler's formula, those things. I have lists of those on my phone that I want to cover. Finishing the Heron's formula video, because we did all the laws of the trigonometric functions. So that's essentially all the stuff that I plan on even getting close to covering in the future. And I just kind of wanted to give a quick rundown of what that was going to be. I'm probably going to intersperse these things throughout the channel. I'm not going to like focus on just the pile of papers and then go through the textbooks. I might, you know, jump through because it's not good to, you know, put all your eggs in one basket. Does that saying even apply here? You know, I just kind of want to keep it a diverse mathematical channel, and I'm quite looking forward to the idea of going through, especially through the... Honestly, you know, I gotta say, I'm kind of looking forward to going through the abstract algebra text because I don't know enough about it. Or, I mean, I do, because I took the class, but I don't know. Now I'm just rambling. I'm especially looking forward to the two analysis books, the number theory book and the abstract algebra book. So, and maybe sifting through my random notes over the past year, 2 years. So, just thought I'd give this little rundown. Thank you for watching, whoever does, and I will see you on the next video.